Welcome back. Up until now, we've been moving data around by passing parameters to functions, returning parameters from functions, and then maybe displaying something to the output screen in one of these cells in Jupyter Notebook. I don't think it'll surprise you to learn that you can also move data around into and out of a file that is stored on your computer. And that's what we're going to talk about in this segment of the lecture. So let's go ahead and start by looking at this little bit of code right here. So in this code, I'm opening a file. This .txt tells me that it's a text file. And this text file, I'm going to switch tabs here for a minute, lives in the same directory as my code. So this is my Python notebook right here. This is the file states.txt. I can just go ahead and open it. You can see it's just a bunch of code. You can open this with any standard piece of software, including Microsoft Word. And what I'm going to do is open it for the purposes of reading. So this second parameter to the open command says, please open this file and allow the code to read from the file. Be very, very careful here. If you had put a W in here, it would have overwritten by annihilating any of the contents in this file for the purposes of writing. And we'll see that in a little bit. So when you only want to read a file, you must specify read only. In file, this variable right here now is a file descriptor or a pointer to the contents of the file. It is not the actual contents, but it will allow you to get access to it in the following way. Very nicely, Python provides a mechanism for reading a text file one line at a time. And it's, of course, with a for loop. So here I have for line, that's my variable name, of course, in file. In file, of course, is the name of the variable that we define from opening the file. Notice this is exactly the same syntax that we would use for reading the elements of a list or the characters of a string. Line will take on the value of each line of the file states.txt one at a time, and inside the body of the for loop right here, you can do whatever you want with it. You can parse it, you can search for it. In this case, I'm just going to print it. So let me go ahead and run this code and let's see what happens. All right, well, let's see. So something a little funny happened. I mean, it's about right. We see Maine, New Hampshire, Vermont, Massachusetts, Rhode Island, et cetera, but there seems to be an extra line here between them. I'll come back to that in a minute. Notice here at the very end of my code, I've opened the file, I've extracted every line, I've printed every line. I now have to close the file. And the way I do that is I say in file dot close paren. There's that same dot notation that we've seen. And I'll give you a little hint to the future. In file is a type of object, and we are accessing a function associated with the object the same way we've done in a few other examples prior to this, including lists. Okay. So we can extract data from a file. So where is this extra line coming from? I'm only printing one line at a time, and if you remember when you looked at the file, there wasn't an extra line. And what this is coming from is that although you can't see it, at the end of every line in the file is a carriage return, is a new line, and that is read in as a character. And so when I print the line, I print that new line that was read from the file, and then I start at the next line below because this, of course, also starts you on the next line. So inside of the file is a new line character that is causing this space here. And you can suppress that in print in the following way. So same thing, I'm going to read the file states.txt for read only, that's the R parameter. I'm going to extract each line in the for loop from in file, and now I'm going to print, and of course you can do this for all print statements. And at the end of the line, I'm going to say, don't put a new line. I don't want a new line. Why? There's already one in this file, so just the new line is the empty string. And now when I run this code, I don't get the extra new line that comes from the print because this already has a new line. So there's just a little feature in print where you can dictate what happens at the end of a print statement. So you can print on the same line or on the next line, depending on what you define here. Okay, so that allows us to extract data from a text file. We can also put information into a file. So let's say you do some big, hairy computation, and you don't necessarily want it to go to the user to read, but you want to save it in the file for future use. You can write. And here's how you write. You, again, get a file descriptor, but this time we are going to open a file that does not exist. So I'm going to use the W command. And what will happen here is that if this file exists, it will annihilate, overwrite, delete anything in the file and give you a blank file to start writing into. If it does not exist, it'll create an empty file, and now you can write into it as follows. Outfile.write, and then whatever you want to put into the file. So notice I have here 4 and 7 years ago. This \n is the new line character. It will force a new line in the actual file. Otherwise, when you write, it'll all be one line. So I'm writing 4 lines. Each of them has a new line at the end, except for this one. I put a space here just to show you that these 2 lines of text will be the same. And as before, I'm going to close the file. Now, when I run this, nothing happens. I mean, it looks like nothing happened. There was no output. But if we go back up to the same directory, we will see gettysburg.txt. You will see there's 3 lines. Here's that one long line without the new line that I just promised. So it writes into the same directory that your code is being evaluated. And of course, you can put a path here to push it into whatever you want in your file system. Okay, good. So we know how to read and write plain text. And this is a nice, simple idea for grabbing some information from a file or shoving some output into a file. Now, as you get into the world of data science, text files will be somewhat limited and you will have to deal with other formats. So one of the standard formats is the so-called CSV format, which stands for comma-separated values. This is a sort of a bare bones format for specifying rows and columns of a data. For example, Excel and Numbers will each export a CSV file, which is a nice portable format that allows you to move it between different software packages without any proprietary hassle. And I don't think it'll surprise you to learn that we can both read and write to CSV. So let's see how that's going to be done. So first things first, you have to import CSV from Python. It's a built-in library, so just go ahead and import it. And then you're going to get access to a number of things. Notice here that the opening of the file is exactly the same. Open us500.csv for read purposes. For reasons that I don't know why, I switched from a double quote to a single quote, but either of them will work. And again, that file, us500.csv, must be in the directory in which the code is being run, or in the folder. So this again gives you read access. Don't forget, if you put a W here, that data is gone. You execute that one line of code, you've annihilated your input file. And now I have to do one more step. This is the file descriptor. And now I'm going to call CSV, which is of course what I imported, .reader, that's the name of the function, with the name of the file that I just defined. And this is going to shove all the data that's in this CSV file into this variable that I'm calling CSV data. And now I can read each line of that data in a very similar way to what I did with the text file. For row, that's of course my variable. In CSV data, that's this variable, and I'm going to go ahead and just print row. So let me go ahead and evaluate that. And you can see here's the output, and it's in this, you can see here's the header. Let's see here, first name, last name, company name, etc., etc. Here is one field right here. Here is another. I'm not revealing, by the way, anybody's personal data. This is a fictional CSV file that you can download from somewhere on the web. So don't worry, there's no privacy violations here. And it just prints one line after the other, after the other, after the other. Okay. So very similar to a text file. You open the file. You need this one extra step because of the special nature of CSV data, which is this comma delimited. You read the whole thing using this reader function. You shove it into this data file, into this data variable rather, and then you can access one row at a time. And then when you get to the end, you have to close the file. So this line of code for opening and this line of code for closing is exactly the same, regardless of whether you're reading CSV or if you're reading text. Okay, good. So there's just, because you'll see this, I just want to show you a slightly different syntax for doing exactly the same thing. So instead of opening the file, extracting the data, you can do that within one of these with constructs, which you have seen before when we use for animation. So we can say with open, US 500 CSV, you don't have to specify read, that's the default, as CSV file. This variable then will be a pointer to the file. CSV data will be the result of reading the data from this file. Those of two of course are of course the same variable. And then everything else is the same within this with. Neither is right or wrong. I just want you to see both because you will see both of those when you're looking at other people's Python code. All right, so obviously we should be able to do more with CSV files than just simply print the data. That's not very useful. So let's look at an example. So here I'm going to, again, open the CSV file, read the data, and here what I'm going to do, because most CSV files have a header, and now I want to get into the data, I can specify to skip the header using this next command. So this simply says to skip the header, and then all the data in CSV data is going to be actual data and not that header, which is the name of the columns. And again, I've got the same for loop now for row and CSV data. And before we were just printing row, you can see it here. This is now a list. And I can access the elements of the list using the list notation square bracket. So here, for example, I can say, please print for me all people who have a zip code 94104. So let me go ahead and just run this. And notice what I'm doing. I'm grabbing each row of the data. There's 500 rows in there. I'm examining the 7th column, which is associated with the zip code. I'm texting for equality. And then I'm printing the first name, the last name, and then the zip code just to verify that I got it right. And I see that there are 3 people in this file with this zip code. So once you read one of these rows, it comes in as a list. And of course, that list is really easy to figure out because this CSV file is comma delimited. And so it separates everything by commas. Everything goes into a column of a list. And then you can parse that data and do various types of simple data analytics and searching. Okay, that's it for this. When we come back, we're going to talk about a different type of I/O, which is that of visualization and graphics. So we'll see you in a few minutes.